Okay, so now we are still on 1.2, which is modeling equations. So I just have some examples for you to take a look at. Looking at another one here, it says a student has an algebra course and they have test scores of 64 and 78. What would the third score have to be to give the student 80%? Um, well, the first one is 64, 78. To find the average, basically to find an average, you take all three, you add them together, divide by 3, and we know that it's supposed to be 80. Because average is you take the total number of them and divide by that number. Well, we know the first test is a 64, the second test is a 78, the third test we don't know. So we add all those up, divide by 3, that equals 80. So multiply both sides by 3. And when I do that, I get 640 plus 64 plus 78 plus x equals 240. Combine those two together and get 142 plus x equals 240. Minus 142 on both sides, and I end up getting x equals 98. So that student would need almost 100% in order to be able to get an 80% in the course. A clothing store has a clearance sale and advertises that all prices have been discounted at 20%. If a shirt is on sale for $28, what was its pre-sale price? Well, if the shirt was 20% lower, that means it's 80%. That means it's 80% of what it was. So the original price then, it would be 80% of that X, and that will give you the sale price. So x times 0.8 equals 28 because, once again, if the original price was 100%, right, you're taking 20% off of it, so the new price of $28 is 80% of that. So 0.80 times x equals 28. We would divide both sides by that 0.8, and we end up finding out the original price is $35. And once again, just see if it makes sense, right? To see if it makes sense. It only went down 20%. If for some reason we got an answer of 65 and it went down to 28, that seems much, much more than 20% that it went down. So look at your numbers and see if they make sense. Two cities are connected by means of a highway. Car A leaves B at 1 and travels at a constant rate of 40 miles per hour towards city C. 30 minutes later, another car leaves B and travels towards C at a constant rate of 55 miles per hour. If the lengths of the cars are disregarded, at what time will the second car reach the first car? Okay, well, car 1 is D equals RT. Car 2 is D equals RT. They're both going the same distance. Okay, so keep this in mind. So the distance of the first car is going at 40 miles per hour, and we don't know the time. The second car is going at 55 miles per hour, but it's going at a half hour less, right? It says it started 30 minutes later, right? So 30 minutes later. The reason why I chose a half hour instead of 30 minutes is because we're talking about miles per hour. So I got to make sure all the units are the same. So that's why this is 0.5 because I'm taking 0.5 away. The distances are the same, so I set them equal to each other. So 55 times x is 55x. 55 times negative 0.5 is negative 27.5. So to solve this problem, I would subtract 55 on both sides. So we get negative 15x equals negative 27.5. And to solve for x, I would divide both sides by negative 15, and I get x equals 1.83333. So 1 whole hour, and that's probably about 50 minutes. 1 hour and about 50 minutes it took. 1 and 5/6 of an hour. 5/6 of an hour, right? If I changed it into minutes, I'd multiply both the top and the bottom by a 10. So that's why it's 50 out of 60 or 50 minutes. So 1 hour and 50 minutes it would take before the two cars were the same at the same exact spot. So at 1 o'clock is when they left. So at 2:50 is when they would physically be at the same exact time. The Continental Airlines fleet includes 727 with a cruising speed of, let's see what the speed is, shall we? 545 miles per hour. And then the next plane, this B 1900D with a cruising speed of 285 miles per hour. Suppose that it takes off and travels at its cruising speed. 1 hour later, so this is the exact same problem as the last one, basically. The rate of the plane is D equals RT. The first plane is the 727 plane. It's going at 545 miles per hour, but it's saying that it takes off an hour later, and this one goes at 285 at just a regular old cruising speed. So 1 hour later, the first plane took off, which is why it's x minus 1. So the speed of the first plane is 545 miles per hour, but it left an hour later. That's what it's saying. Left an hour later. The airplane 2 is going a little slower, but it just left at its regular time. So we set them equal to each other. 545 times x is 545x. 545 times 1 is negative 545. So I combine my like terms by subtracting a negative 545x. This way I get all the numbers on one side and all the x's on the other. I divide by negative 260 on both sides. And we end up getting x equals 2.096. So about 2.1 roughly. So 2 hours and 6 minutes, because I'm looking for what makes it 60 minutes. 2 hours and 6 minutes roughly. How long will it take them? It'll take them about 2 hours and 6 minutes before they're at the same exact spot. And the speed of an Amtrak passenger train is 14 miles per gallon faster than the speed of the Central Railway's freight train. The passenger train travels 400 miles in the same time it takes the freight train to travel 330 miles. Find the speed. So, Amtrak train, same time is the key. So, before we were setting distance equal. Now we're setting time equal because they said the same time. So, when I'm doing this, I'm going to solve for time. So now I'm actually going to do d over r equals d over r when I do this problem because the times are the same. The first one goes 400 miles, and it says it goes 14 miles per gallon faster. So this is x plus 14 because it's the speed plus 14 gallons. This one goes 330 just times whatever the miles per gallon are, and that's what we're trying to find, what the speed is. This one, it says right here, the first Amtrak train is going 14 miles per gallon faster. That's why it's plus 14 on the bottom. So we cross multiply. 400 times x is 400x. 330 times x plus 14. Well, I distribute to get 330x. And 330 times 14 is 4,620. So I minus 330, and I end up with 70x equals 4,620. I would divide by 70 on both sides to get 66. So what that means is that freight train is going 66 miles per gallon, and the Amtrak is actually going 80 miles per gallon. So if that should have at least helped out with the distance ones to help them be a little more clear, because there was about 3 or 4 straight problems like that. Hopefully, I can get some more problems related to the chemist ones and the milliliter ones and the antifreeze and the 30% and things like that. So I'm hoping to get some more of those on a little bit. So stay tuned for that. If you have any other questions or concerns, please let me know.